Well, greetings everybody. So today I got this question sent to me about homework assignment number 3. Here's our question, and it's about the binomial distribution, but let's just read it at face value and talk about how we can get the answer. So it says, to start with, we're just given some information. 79% of US adults think that political correctness is a problem in America. Okay, so, if I had 100 people and I asked them, do you think political correctness is a problem or not? We'd expect 79 to say yes, okay? And the other 21 to say no, under the assumption that they're either going to say yes or no, okay? Now we'll select 6 people at random and ask them whether they think political correctness is a problem or not. And then, from there we're directed to the questions, okay? So it says find the mean of the binomial distribution. Now, before I get into that, let's say that this is something that I would call a binomial experiment, okay? And I'll detail what about that we need to be aware of, okay? But I think that before you understand what I'm going to do here, we'll have to know what a binomial experiment is and how to recognize one, okay? So that I won't go into. I've already made a video about that, and it's right here. Okay, under the very first video for MyMathLab assignment number 3. So let's say that we understand that, okay, that we know how to recognize a binomial experiment when we see one. In this case, our binomial experiment is we're going to ask a person, do you think political correctness is a problem or not? And they're going to say yes or no. The probability of yes, given that information that we were given in the question initially, 79% or 0.79 as a decimal. The probability they'll say no, okay, 21% or 0.21 as a decimal. Now we'll randomly select 6 people and ask them. Now anything can happen. I might select 6 people and they all say no, or maybe they all say yes, or maybe some mixture of yes and no, okay? All right, now from here we will calculate the mean, the variance, and the standard deviation. That's what this question will ask us, okay? It says first find the mean, then it's going to say find the variance, then the standard deviation. Now there are standard formulas for doing that, but I need to start with this. In our binomial experiment, n will always be the number of trials. So we're not just going to ask a person, is political correctness a problem or not? We're going to ask 6 people and tally the results. See how many out of the 6 say yes and how many say no, okay? So n is the number of trials. In my case, that's going to be 6, okay? Because it said that we're going to randomly select 6 people and ask them, okay? P is the probability that they'll say yes, okay? So that's 0.79. 79 out of 100 are expected to say yes. And Q will be the probability that they'll say no, which is the other option. And that will be 0.21, okay, because Q is always 1 minus P, okay? Think about it. If I said, well, 79% say yes, that means if you had 100, 79 out of the 100 would say yes, and the other 21 would say no. 100 minus 79 is 21. It's like that. Okay, so the mean is N times P. The number of trials times the probability of yes. So that's 6 times 0.79, that's 4.74. Okay, so let's see. 4.74, that's what I need. I calculated this. It says round to the nearest tenth, so 4.7. All right, 4.7. And then we got it right. And it says find the variance. Okay, well, the variance is going to be N, the number of trials, times P, the probability of yes, times Q, the probability of no. So when I did that, I got 0.9954. Again, it says round to the nearest tenth. So how do we round 0.99 to the nearest tenth? Well, that would have to be 1. All right, 1. If that was 0.93 or 0.94, or 0.92 or 0.91, it would round to the nearest tenth as 0.1. But rounding to the nearest tenth, I'd have to bump that up from 9 to 0 and then make this next digit a 1. That's why it rounds to 1. Okay? Alright, so round to the nearest 10th. It's a little weird this time, but yeah, 0.99 rounds to 1. And then the standard deviation is the square root of n times p times q. Okay, and I did this again in my calculator and I get 0.9977. But it says round to the nearest 10th again. Okay, so that will still be 1 rounded to the nearest 10th. Alright, so I got that. Then it asks us to interpret the results. Now, and I'm given this statement to try and figure out. Most samples of 6 adults would differ from the mean by no more than blank. Okay. Now, the way that this works is that the fact of the matter is most samples of 6 adults would differ from the mean. So, all right, in most, like we're going to get on average, if we ask 6 people, do you think political correctness is a problem or not? We're going to get about 4.7 on average, okay, and, all right, that's just an average, say yes. Okay, so you ask 6 people, you ask 6, say you did that over and over and over, and you averaged how many said yes out of the 6, it'd be about 4.7. Okay, but there'd be some variation. All right, it wouldn't all be 4.7, some be a little more, some be a little bit less, and so on. That's where the standard deviation comes in. Most samples of 6 adults would differ from the mean of 4.7 by no more than 1 standard deviation. So what goes here is the standard deviation, whatever it is. And in my case, that's 1, okay? Yeah, so, you know, most samples are going to be, like, if I average them, I'm going to get 4.7 out of the 6 say yes, but most samples are going to fall between 3.7 say yes and 5.7, okay? That's the way it's going to look if you did this over and over again. All right, so put that in. Fantastic. All right, so that's how you do that. We've got some standard formulas that we use to calculate the mean, variance, standard deviation. But beyond that, we're going to see that most samples differ from the mean by no more than 1 standard deviation, whatever that standard deviation is. We've seen that before in other distributions, and so we've seen something similar with the empirical rule, and but that's the fact of the matter with this type of problem.